using the wooden piece or maybe the soil, yeah, gypsum related. Today people have a money, a finance, so at least they're going with the composite or some other materials. Okay, but of course this is one of the requirement when you go for the designing the aircrafts. You should have at least experimental data available, not just CFD data, correct? CFD is fine, theoretical analysis you can do. You can design very advanced models, optimized designed, then you can do the CFD analysis or flow analysis like aerodynamics analysis. So you have of course good designs. Then you again you can go with the FEM structural analysis. Means if you pick up the materials, then you have idea what are the pressures can hold, what are the various these structural variations will be there in terms of the pressures or in terms of the strength, correct? So different materials at different locations you can change, but the idea is there, that is the software analysis. What about the actual, when we are talking, when we manufacture the hardware, we should go further, either in terms of the structural testing or in terms of the your aerodynamic testing, correct? So aerodynamic testing is one of the your wind tunnel. So you should have model. Okay, in the wind tunnel models you should have a sensors first, and it should check what is the maximum what is called cross section of the wind tunnel, correct? So this is 9 by 14 feet, so 9 feet height and 14 feet. This means you can go ahead with around 12 feet this much, and at least 8.5 or something. 9 feet you can't go, correct? That will hit the this wind tunnel itself. So you should have clearance, like air should pass, not just like hitting this and going. Okay, so you should have clearance from all directions. That is one thing. And so you put the aircraft which should be as per the cross section area of the test cross section area of the wind tunnel. Okay, and I was there during when Bombardier aircraft tested. I think that is the similar type of aircraft, 10 feet aircraft designed, and all being was with the pressure sensors imported integrated inside, just like a wing was 24 lakhs cost. Okay, so when you see, then that is one requirement. Then you should have wind, what are the speed you require. So you should have something fans, correct, which will give you the particular wind speed, so that will drag. Okay, so particular speed will be coming. So that is one thing. Then there are meshing, like mesh inlet side, which will make a smooth air. Okay, every section of the every point of this test section should have the same velocity. Okay, that's the environmental conditions we are talking now. Then many static system will be integrated in the wind tunnel to monitor the your air speed at different locations. Then you will see the density also to measure. Some sensors will be there. Okay, so temperature sensors, then pressure variations, lots of sensors will be integrated to monitor what is the wind tunnel environment itself. Then comes, you should have a model, one model, and model load. Model load is very important. So you should have load cell, which is called 6 component strain gauge balance, correct? So you should have load sensor, load sensors. Load sensor is actually inside here. So once you have like a setup, then sensors are inside, and sensor will be like a mostly a strain gauge sensor. Okay, which will be connected through the electrical wire. Okay, electrical wire, and this will be available in the computer side to get that voltage. Okay, so all the sensors will give you voltage data, and that voltage data further will be converted in terms of the G or maybe pressure. Okay, based on the further mathematical model you will get CLCD. So I will show you what are the parameters, what type of data generated from this. So there's the one thing, and this is the static. But what you can do, this soft, yeah, these systems can go inside. Okay, so this can change. So what this happened, this will make the angle of attack. Okay, so if your wind direction is not changing, wind direction will be in the same, only you are orienting the direction of the aircraft. Okay, nose direction of the aircrafts. So this becomes the some reference, like your reference wind, what is the wind direction is the same, but your this direction changes. So that is called angle of attack there. And other thing what they can do the yaw also. So mostly they are looking the side slip as well as the yaw angle. So they can change here. So like you have angle, okay, not just angle of attack, but side slip also can get. Yeah, yaw angle at least you will get. Roll facility is not there. If you want roll, then you should have another setup here which rotates. Okay, means you can rotate the your models. So normally what is the requirement there? You should have load cell like a strain gauge balance sensors. Okay, which require based on the your weight of the aircrafts. Okay, if you want to test, let's 3 kg, you cannot use the 10 kg or 50 kg type of sensors. Okay, so you should go with the let's 3 kg or 5 kg type of sensors are there, means maximum can test 5 kg. And if you want let's 50 maybe 10 kg 20 kg type of aircraft should be tested, then at least you have 10 to 50 kg type of sensors, means that the threshold load sensors require. So that is the meaning we cannot use 50 kg type of load sensor to test the 2 kg type of aircrafts. Okay, you will get a wrong data. So that is the important when you are testing inside the wind tunnel. And then this was very complex activities. This was one of my project during the ISC, and this is the first time tested in the wind tunnel in the ISC. Long back only through blade was tested. That was the static. Okay, so this was like a, you can tell like in ISC first time. So all professor was worried about that what going to happen with the wind tunnels when you're testing inside. Okay, and this was running conditions. Previously never happened running condition inside the bindle. So I will show you this and then I will show you the data today. Just just one test first. What we do before testing the models. Okay, so if you are testing the model, what is the basic requirement during the conceptual designs or preliminary designs? Means you should not test the model, you should test the setup first. Okay, so you will get the setup test related CL/CD all variations, because this is going to be added with your aircrafts. Okay, so any weight or any setup what you put, okay, all weight acting on the sensors. So those sensors data going to be considered during the your actual test. So this is a very important point. Most of the people they will forget, but when you do this type of activity, let's you have at least test setup test data, and that going to subtract from the actual test data. So this was tested a static wind without a wind, then with the wind. Okay, so I think you are seeing correct. So then we have tested a little variation also. Otherwise normally you need at least at zero angle of attack. Okay, so zero angle of attack you can test this. And all data is loading in the computer side. Then after once you have tested this, then you will get tested this type of. So like too much acoustic, too much sound was there, that there was worry about all this, like what are the problems are coming with the testing of this. So we supposed to write the all failure cases also if anything fails inside. Every person was worried because when you see this actual test inside the wind tunnel, uh, pilot has given the complete throttle. Okay, so aircraft was supposed to take off, but the system was holding. Okay, and because that this system failed inside, complete swash plate mechanism got like damaged. So free engine was not operating the blade itself, like auto rotation you are knowing correct. So this happened inside the wind tunnel, and no one was knowing what happened. Then again realized because you have given the full throttle, so aircraft supposed to take off correct, but this system was not permitting to take off that. Okay, so these are things. And data what you will see, I think just I will show you the data. Mostly you will get data like this. Okay, So we start with all the parameters which required. You should have a wind speed, time, those things will get captured. Okay, and is it wind on, wind off conditions? If wind off means you should not run the fan, correct? Instead the static, yeah, with the what is called 3 meter per second wind normally will be there, correct? So we are capturing that. But when you given the, yeah, if your fan is rotating, then what is the speed you reached, correct? So 12 meter per second if there inside the wind tunnel, then that velocity will be considered relative velocity of the aircrafts. Okay, then you should have being a span area, then reference, okay, chord. So mostly we are looking from the nose. Okay, all those points, these are the points required: fuselage, nose, then from the fuselage reference line, from the balance center, like where you put the sensors, all those before like setting of your system. Because if you're not giving this data, you can't get this data. Okay, so all these data require, so you should have proper calculated. Okay, you should have spent time for looking all these parameter again, because you're testing, one test costs 50,000. Okay, if you're flying just like testing for 1 hour, they will charge huge. Okay, our project was there, so there is no question about that, correct? But if you're talking about the 100 test or 1,000 test like Tejas aircrafts, then you, of course you should pay for that. So what is this? This is the zero angle of attack, tested for zero angle of attack. Okay, this is the velocity, this is dynamic pressure inside the wind tunnel, and then this is the body axis related. Okay, so you have the z direction, in the x direction, in the lateral direction, then pitching moment, rolling moment, and then yawing moment. These are the coefficient in the body axis. This is the wind axis, like lift coefficient, drag coefficient, then lateral coefficients, then pitching moment, rolling moment, yawing coefficients. Okay, so all data you will get calculated, and then further you can go ahead with the analysis, like a CL versus alpha, we can do that. So if you check the another parameter, I think then you will get the idea. What is that? Yes. Different data. Yeah, this test tested at different angle of attack. Started with the -6, -4, -2, 0, 2, 4, 6, 4, like that, continuous. We are looking his stresses. Okay, you should not stop like one test. You should go back again. Otherwise, you can't get his stresses loop. Very important point, because sensors, what they will do, they will capture the previous data also. So there are lots of analysis during the testing itself. Means is it when you stop your sensor and started again, is it the same sensor data, or is it previous data recorded there or not? Okay, so we have to do the various test with the different angle of attack, different wind speed. Okay, so and if you are looking like a different side slip also, then you have to do that. Okay, so I think side slip we have not captured, already failed after I think 6 or 7 tests inside the wind tunnel. Then we have stopped that. Okay, because we have tested the off condition, we have tested the helicopter on conditions. Okay, and during the on conditions, one first time itself failed. Okay, off condition we tested, on conditions he has given the full throttle, because that this problem has started, so we have to stop that, correct? So there was worry about that. Means maybe load sensor will fail, strain gauge balance sensor will fail. So lots of factors comes when you have vibration type of systems testing inside of the wind tunnel. Yeah, so I think this much was there related to the your conceptual design when you're talking about the wind tunnel testing. And flight testing, if you talk similar way, like aircraft also you can place. This is the helicopter, so we talk the helicopter. And other way you have flight test data. So start with the flight test data. I'm not showing the video now. You can go through the YouTube's, is there. Okay. So tested with the various maneuvering phases, like I think if I want, let's see. So they do that like a inverted different. So same way, like you can go ahead with the fixed wing type of the models. I think hanging now. Yeah. So just see one model. Just like the full roll, full pitch, full like a inverted every like, or this inverted. So just I given